So then let's go a little further to look at logistic regression as a neural network. Now we have, in logistic regression, we have some nonlinear feature in the model. So in logistic regression, assuming we have M training samples, that's X1, Y1, X is the input, Y is the output, and to XM to YM. Each X1 to XM here is a vector because for each sample, you will have a list of features, not just one feature. It's likely to have a list of features. Here, each X has an X number of features. So the number of features in rows in this, if you put it all together, you can stack it up, you can get a matrix X. It's a little counterintuitive to people from stats background because we usually, as statisticians, we like to notate the different number of features variable as P, and it's the column, right? Here's the rotate. So the number of features are each features, each row, and each column is each sample. So you have M sample, and then you have M output, that's Y. And in logistic regression, we have linear combination of all those input features, and then we plus the bias term, and then we get that accumulated signal. And then we apply an activation function. That's something new here, different from perception. We apply an activation function, and this activation function oftentimes is nonlinear function. And after we apply this activation function, we connect in logistic regression, we just connect that with the output. That's Y hat, because it's a sigmoid function that will transform this number to be a number between 0 and 1. And then we want a way to update the model, to optimize the model, then we need a target, what to optimize. That's the loss function. So you need to measure the distance between your prediction and the real value Y. So that's the loss function here. It's Y hat and Y. And this here we use entropy. Entropy is a very common loss function for categorical problem, classification problem in deep learning. This is for one sample. If you have M sample, you need to average over those M sample. You get a cost function. I might just use loss and cost interchangeably. It's very similar thing. Cost is just average over all the loss. And then the goal is to find the parameter value that minimize the cost, JWB here. So how to optimize this is very simple. As mathematician, you will just get derivative with respect to each of these parameters, and you update it using the derivative multiplier learning rate. That's how you update each parameter.